Keeping up with our motto, let learning be a joy and teaching a pleasure. Here we are with the remote teaching and learning process to bridge the gap. Happy learning, students.
Hello students, today we are going to see a chapter from Science and Technology Part 1. Chapter number 2, Periodic Classification of Elements. Now when we are talking about elements, the very first question which comes is, what are elements? Yes, a substance made from entirely one type of atom is called elements. Now, since we are talking about elements, we should be aware how many elements are known to us. Correct. That's 118 elements. From this 118 elements, how many are naturally occurring elements? These are 94. Whereas the elements which are prepared artificially are 24. So in this chapter, we will discuss how these elements have been classified along with certain properties. The first scientist to come forward was Reiner, and his law is called as laws of triads. According to him, properties of an element are periodic functions of atomic masses. He arranged the three elements having similar properties in a group of three called as triads in such a way that atomic mass of middle element was the approximately mean of the other two elements. However, all the known elements could not be classified into triads. As a result, his idea was cancelled. The English scientist John Newland correlated the atomic masses. He arranged the elements in a group of 8 in such a way that every 8th element has the properties similar to the first element. He arranged all the 56 elements in a table of 7 by 8. However, his law was found to be applicable only up to calcium. As a result, again his idea was cancelled. After him, the Russian scientist Dmitry Mendeleev considered the fundamental properties of the elements and arranged the 63 elements which was known at that time. Now, his table is considered to be most important because of certain points. Those points are considered as merits of Mendeleev periodic table. The very first thing what he has done is, he has atomic masses of some elements were revised. He noticed that there were corrections in the atomic masses of certain elements. So he revised the atomic masses of some elements. Secondly, he left out 3 empty places in the periodic table and predicted their properties. That is considered as his very important achievement. He named them as Eka boron, Eka aluminium, and Eka silicon. Later, these elements were discovered and named as scandium, gallium, and germanium. This achievement made by Mendeleev is most important. Thirdly, there were no place reserved for noble gases. However, when noble gases were discovered, they can be arranged without disturbing the table. So that is considered as his merits or advantages of Mendeleev periodic table. But later on, it was noticed that there are certain drawbacks in this table. Now, those drawbacks are noted as demerits of Mendeleev periodic table. The first problem was the whole number, atomic mass of the elements cobalt and nickel is the same. Therefore, there was an ambiguity regarding their sequence. Secondly, isotopes were discovered long time after Mendeleev put forth the periodic table. As isotopes have the same chemical properties but different atomic masses, a challenge was posed in placing them in Mendeleev periodic table. Thirdly, when the elements are arranged in an increasing order of the atomic masses, the rise in the atomic masses does not appear to be uniform. And the last very important thing was there was an ambiguity regarding hydrogen and halogens. That is, where the hydrogen and halogen should be placed. After the discovery of electron, scientists started exploring the relation between electron number of an atom and the atomic number. In 1913, English scientist Henry Moseley revealed that atomic number is a more fundamental property of an element than its atomic mass. So, he stated that properties of an element are a periodic functions of their atomic number and not atomic mass. So, according to him, he has prepared a table which is called as modern periodic table. According to his modern periodic table, it consists of 7 horizontal rows called as periods and 18 vertical columns called as groups. Apart from these 7 rows, 2 rows are shown separately at the bottom of the table. These 2 rows are called as lanthanides and actinides. The entire periodic table is divided into 4 blocks. First is S block, which contains group 1 and 2. They are called as normal elements. Second is P block, which contains the group from 13 to 18. They are also called as normal elements. Third is D block, group 3 to 12. They are also called as transition elements. And the last is F block group, which is placed at the bottom, which are called as inner transition elements. The 3 traditional types of elements can be clearly shown with the help of zigzag line. The metalloids lie along the border of the zigzag line. The metal lies on the left hand side of the zigzag line, and the non-metals lies on the right hand side of the zigzag line. Now this can be seen in the periodic table which is shown on this slide. Next is the groups and electronic configuration. The number of valence electron in a group is the same. That is, while going from top to bottom, one electronic shell gets added at a time. From this, we can see that electronic configuration of the outermost shell is the characteristics of a particular group. Next is periods and electronic configuration. In a period, valence electron is different. However, the number of shells is the same. While going from left to right, within a period, the atomic number increases by 1 at a time, and the number of valence electron also increases by 1 at a time. Elements with same number of shells belongs to the same period. The chemical reactivity of an element is determined by the number of valence electron in it and the shell number of the valence shell. Now that was about the periods and the groups in the modern periodic table. The next is periodic trends in the modern periodic table. There are certain periodic trends which we are going to discuss in this chapter. The first is valency. Now what is valency? Valency of an element is determined by the number of electrons present in the outermost shell of its atom. That is the valence electron. And in a period, as we move from left to right, atomic number increases. As a result, valency increases first and then decreases. Whereas in a group, as we move from top to bottom, valency remains same, as the number of electrons in the outermost shell remains the same. The second point is about the atomic size. Atomic size means the size of an atom, and the size of an atom is indicated by its radius. So atomic radius is the distance between the nucleus of the atom and its outermost shell. In a period, as we move from left to right, atomic number increases. As a result, atomic radius decreases due to more electrons in the outermost shell, resulting in decrease in atomic size as the attraction increases. So in a group, the atomic radius increases as we go from top to bottom, resulting in increase of outermost shell. As a result, the atomic size increases. The last property is the metallic and non-metallic characters. In a period, metallic character decreases as we go from left to right, because the number of electron increases. As a result, the attraction increases. Whereas in a group, metallic character increases as we go down the group. So that is about the metallic and non-metallic characters. Thank you.